welcome in Untitled Chapter, Faculty of Engineering and MBA. Today, in Power Electronics subject, next point is PUT. In previous lecture, we seen the UJT, that is the SR triggering device, that is unijunction transistor. Now, in this lecture, we have to learn the PUT, that is the programmable unijunction transistor. Programmable unijunction transistor. First of all, see its construction diagram. Here, I will draw the construction diagram for the PUT. PUT is nothing but the four-layer structure having alternate layer P, N, having three terminals: anode, cathode, and gate. These are the three terminals having three junctions: junction J1, junction J2, and junction J3. Now, from this diagram, we observe that the gate terminal position is replaced in PUT, that is programmable unijunction transistor. In SCR, the gate terminal is at P region, and in PUT, gate terminal is at N region. Means we can say that this gate terminal is closer to the anode. Now, I will draw the symbol for this. This is the symbol. Same as that of the SCR, that is anode, cathode. And in SCR, we draw the gate symbol here. But in programmable unijunction transistor, gate terminal is closer to the anode terminal. Hence, this gate terminal is also called as a anode. Only one difference is that the position of the gate terminal. Now, see its construction. In this construction diagram, here the three, as told before, three terminals are there: anode, cathode, and gate. Four layers are there: P, N, P, N. Alternate P and N layer are there. And three junctions are there: junction J1, junction J2, and junction J3. Then this structure is a vertical structure. Here you can see that this structure is a vertical structure, same as that of the SCR. Only one difference is there, that is the position of the gate terminal. All constructions will be same as that of the SCR. Now see, this is the programmable. P for programmable unijunction transistor. UJT and PUT, one difference is there, that here we can do the programming. Means flexibility can be increased due to the programming. Now see its characteristics, and then from characteristics I will explain the working principle of PUT. Here on x-axis current is there and y-axis voltage is there. This voltage is called as the emitter voltage. This current is called as the emitter current. Now see the characteristics. These characteristics are same as that of the UJT. Here, this is the peak voltage. Before this, that is the cutoff region. Next is up to this negative resistance region, and after that saturation region. Now this point is called as a valley point. And at this valley point, voltage present is called a valley voltage and current present is called as a valley current. These are the characteristics. Now I will explain the characteristics of UJT. Here, name this figure as characteristics of PUT. Now see, these characteristics of PUT is nothing but the graph of voltage versus current. Hence, these characteristics of PUT also called as the VI characteristics of PUT. Now here VE, that is emitter voltage, versus RE, that is emitter current, graph is there. This graph is divided into three regions. First region is cutoff region, second region is negative resistance region, and third region is a saturation region. Now see one by one. Its characteristics same as that of the UJT. See one by one. First is cutoff region. Now what happens in this cutoff region? Cutoff region means your applied emitter voltage. This applied emitter voltage is less than peak voltage. Here peak voltage point is there, and when your applied voltage is less than peak voltage, that is emitter voltage is less than peak voltage, in this case your PUT is in off condition. We can say that PUT present in cutoff region. Now see first case. Your applied voltage means your emitter voltage is nothing but your applied voltage. This emitter voltage is less than peak voltage. Means your emitter voltage means applied voltage less than peak voltage. In this case, your PUT is in off condition, and it is off condition means present in cutoff region. It is present in cutoff region. Now see second case. Second region I will show there. So observe characteristics. Second region is negative resistance region. When your emitter voltage, that is VE, reach to peak voltage or greater than peak voltage, reach to peak voltage or equal to peak voltage, at that time your PUT get turned on. Your PUT get turned on. Now see, again see these two conditions. First condition is your emitter voltage less than peak voltage, means your PUT is in off condition, means present in cutoff region. And when your emitter voltage equal to peak voltage, means your applied voltage reach to peak voltage, in this case PUT gets turned on, and after that by increasing emitter current, observe on x-axis emitter current is there. By increasing emitter current, your voltage goes on decreasing. This region is called as a negative resistance region. This cutoff region, second region is negative resistance region. What happens in this negative resistance region? In negative resistance region, by increasing, when your PUT get turned on, by increasing your emitter current, voltage goes on decreasing. This decreasing voltage means your PUT goes in negative resistance region. Now third region, that is saturation region. Now observe what happens in saturation region. Third is saturation region. Now observe what happens in saturation region. In saturation region, when you are after certain limit, your emitter current goes on increasing, also your emitter voltage start increasing, and this point, at this point is called as a valley point, means your PUT goes in saturation region. See again, in saturation region what happens? By increasing your emitter current, your emitter voltage start increasing after certain limit, and this point is called as a valley point, and your PUT goes in saturation region. This valley point is present when, in this case, after certain limit, your current start increasing, voltage start increasing. This is a valley point, and the current present at this valley point is called as a valley current, and voltage present at this valley point called as a valley voltage. This is the point PUT. Now see next point, that is the LASCR. Next point is LASCR. here A, SC, R. Now see, LASCR, long form, first of all see the long form of LASCR. LASCR is nothing but light activated silicon controlled rectifier. Now I will show here the already SCR lecture will be there, and in SCR we learn all the points. I will explain only the difference in LASCR and SCR. Now see what is the difference between SCR and LASCR. Now its name indicates that light activated silicon controlled rectifier. Means only one difference is there. I will show the by diagram. Here 4 layers are there, alternate P and PN. Same construction will be there, having alternate layer P and PN. SCR structure will be same as that of this. This is the anode terminal, this is the cathode terminal, and here at P region your gate terminal is present. But what is the difference between light activated silicon controlled rectifier? Instead of gate terminal, we incident the photons on this gate terminal to convert it into forward bias. Because to run the SCR in forward bias, only at junction J2 is in reverse bias. See here, this is junction J1, this is junction J2, and this is junction J3. Now see, here J1, J2 and J3, already when we connect this anode terminal to the positive of the battery and this cathode terminal to the negative of the battery, what happens? Your junction J1 and J2, J3 goes in forward bias. Only junction J2 is goes in reverse bias. And due to this junction J2, depletion layer get formed, and due to depletion layer, there will be the problem to flow the current from anode to cathode. Means at that time what we do, we connect here gate terminal and connect the gate terminal to the positive of the battery. Means gate pulse is provided so that depletion layer get reduced or get breakdown and easily current start flowing from anode to cathode. But in light activated silicon controlled rectifier, we instead of gate terminal connected to the positive of the battery, we incident the photon on this junction J2. So that what happens? Here depletion layer gets formed due to reverse biasing, and this depletion layer, this light incident on this junction helps to break down this depletion layer. So that when this depletion layer get break, means your current start flowing from anode to cathode easy. This is the difference between SCR and LASCR. Only one difference is there. Which difference? This difference is nothing but instead of gate terminal, we incident the photons on this. All of the working principle of SCR will be same as that of the LASCR. Then characteristics of SCR will same as that of the same for the LASCR. No difference will be there. Now, see here. The main point is what is the difference between UJT and PUT. We learned UJT in previous lecture and PUT in this lecture. Now see difference means comparison point between UJT and PUT. First comparison point is number of junctions. Now in UJT only one junction is there. Which junction? That is the PN junction. We learned in previous lecture. And in PUT, here we will observe junction J1, junction J2 and junction J3. 3 junctions are there. This is the basic difference. Main difference, that is in UJT only one junction is present. In PUT 3 junctions are present. Now second difference point is value of intrinsic standoff ratio. For UJT, intrinsic standoff ratio is constant, but in PUT can be adjusted with the external potentiometer. Because we know in UJT its intrinsic standoff ratio is totally depend on the resistance value, and resistance its equivalent circuit resistance present are there, that is RB1 and RB2 will be having the constant value. So that intrinsic standoff ratio is constant there, and in PUT it can be adjusted with the help of programmable. Programmable means what? We externally use the resistance and do the programming. So that what happens? The intrinsic standoff ratio can be variable if we here negative resistance region. Almost we can say that characteristics of the UJT and PUT are almost same. Now symbol construction, symbolic difference will be there. In previous lecture we draw the symbol for UJT. UJT symbol is in this way. Here this is the emitter terminal, then base 1 and base 2. This is the symbolic representation of the UJT and this is the symbolic representation of the PUT. Now next point is applications. UJT is used as a triggering device for the SCR, then also used as a triggering device in timers, relaxation oscillator, etc. And your PUT is used as a triggering device in timers and relaxation oscillator. And next comparison point is in UJT programming is not possible, hence flexibility is less, and in PUT programming is possible, hence flexibility get increased. These are the comparison point between UJT and PUT. Now next comparison point between SCR and LA-SCR. SCR is nothing but silicon control rectifier and LA-SCR is nothing but light activated silicon control rectifier. Basic difference between this is gate terminal, in LA-SCR no need of gate terminal. Here instead of a gate supply we can provide the inserting the photons on this junction J2, and in SCR we connect the gate terminal to the battery or to the supply. This gate terminal is provided. All other points are same, that is its characteristics, its working principle. All points, its junction, number of junctions, number of layers, number of terminals, all points will be same for the SCR and